Covalent bonding, as we've just explained, helps us to understand how nonmetals can bond to each other. Let's take a deeper look at this and see how this electron sharing really works. A nice place to start, and this is probably how some of the early chemists did it, was to consider those elements that don't do it at all. Elements like neon with its 8 valence electrons. Let's draw them as an electron dot structure using 2 electrons on each side of a square around this neon atom. These could be thought of as orbitals here, or simply pairs of electrons that always add up to 8. 8 seems to be the magic number for just about all the elements in terms of valence shells and stability. So this arrangement is very, very stable, apparently. If we draw some of the other elements, in fact, here's the 4 most common elements used in living things, we can see that none of them have those 8 electrons. Let's spread them out using our electron dot structures. We see that hydrogen has 1, oxygen has 6. Don't draw your 3 pairs. Try to spread them out as much as possible, and this should work. Nitrogen 5, and carbon 4. You may recall that this quick analysis can allow us to predict not only the bonding behavior but the shape of these simple atoms. This will form 1 bond to become isoelectronic with helium. It wants to have 2. The others all, of course, want 8. Oxygen needs to gain 2, so these can act as bonding electrons. These are called lone pairs. It'll tend to form 2 bonds. By this analysis, nitrogen will tend to form 3 bonds, and it does, with 1 lone pair which occupies space. This will be important when we consider VSEPR, also known as a shape analysis. And here's a carbon atom which will form 4 bonds and be very, very versatile. You may recall we talked about the limitation of ionic compounds in that they are simply binary in nature and really don't get too much complexity. Here, this could be bonded to anything, 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 and so the possibilities are endless. Number of bonds, 1, 2, 3, 4. Lone pairs, 0, 2, 1, and 0. Do you see it? This little GIF animation here should help you understand the essence of covalent bonding. Wants 1 electron, wants 1 electron. Now imagine them coming together like that. 8 electrons like that by sharing, 8 electrons like that by sharing. This is the essence of covalent bonding, and this type of analysis with these circles not only shows you the stability obtained by each atom, how they have 8 now, but it also shows you by the union of those 2 circles where that covalent bond is and helps you recognize that a bond is, generally speaking, a pair of electrons. This is a little bit about covalent bonding.